The central limit theorem is the reason statisticians can make reliable conclusions from small samples instead of measuring entire populations. Without it, much of modern data science and quantitative finance and trials simply wouldn't work. Let's take any distribution from last video, say uniform. If we take a large amount of average random samples, we can actually show this as an approximate normal distribution. So I'm going to give an example here. Let's roll a dice. This is a uniform distribution as every outcome has a 1 in 6 chance of happening. Now let's roll 5 die at once and then take an average of the 5 results. Say I got 2, 5, 1, 6 and 4. We'll average this out to 3.6. Now roll them all again. Let's say this time we average 3.4 and so on. Just keep doing this. Let's say we have done this 1,000 times. Now I will show you a quick Python code simulation to show what I've just said. I roll a die 5 times by taking a random number between 1 and 6. Then I take the mean from those 5 dies and then store that as a new result in my data frame. Let's display this with a frequency in a histogram. And we can now see a normal looking bell curve appears if you were to trace all the histogram blocks. No equations, just intuition. Very low averages require lots of low rolls. For example, 1.2 would need a lot of 1s to be rolled, which is very unlikely. And similarly for an average like 5.1. But let's say 3.5, there are absolutely loads of combinations that can produce that, so the middle is a lot more frequent. This is the central limit theorem. Regardless of the original distribution, if we repeatedly take sufficiently large random samples and calculate their averages, those averages tend to follow a normal distribution. But don't get it confused, the sample means are becoming normal, not the original data. Now that we have a nice way of getting distributions into normal distributions, using the central limit theorem, it is a great way to estimate averages of distributions, and now we will have ability to produce confidence intervals and hypothesis tests, which we'll be getting into the next videos. Thank you very much for watching this video. If you found this video helpful, please like the video and subscribe to support the channel. I hope to see you in the next video.